Thank you, everybody. Thanks for the very warm welcome in Israel. Much appreciated. First of all, I would like to thank Tashtiot and Telemania and indeed Sheneve Paper Industries for giving us the opportunity in Israel. The Sheneve project is the very first gas engine of Rolls-Royce Bergen engines, and I would like to add that working with an EPC contractor like Telemania makes life a lot easier. They are a company with a lot of ability, a lot of good people, and it's easy to work with. So thank you to Telemania for that as well. I would like to move on and show you our capabilities as Rolls-Royce Bergen engines, and we would like the Sheneve project to turn into many more projects in this area of the world. So this is me, Mike Carr. I'm Senior Projects Manager for Rolls-Royce Bergen engines, and my colleague over here is Hans-Peter Homadal, and he's a Senior Service Superintendent covering the commissioning of the engines. So you know that I think everybody knows the name Rolls-Royce. We have Aerospace Division and Land and Sea. We are part of Power Systems, and under Rolls-Royce Power Systems you will see MTU engines, on-site energy, L'Orange injection systems, and our Bergen engines. This is the manufacturing facility in Bergen Engines, Norway. So if you have one of our engines, or preferably 10 of them, then you have the visit to go and witness your engines on the beautiful fjords of Norway in Bergen. So you can see the facility, the factory, and you can see the dedicated docking facility where we load the engines onto ships all around the world. And that's a very deep water fjord. We have test beds for full-scale testing of the engines, full research and development to get the very high efficiencies, and we have in the background the foundry nearby. Our engines are medium-speed diesel and gas engines, 750 RPM, and we're capable of full power plant design and implementation, and we have an interdependence between land and sea and product systems and aftermarket. This is the power range for our engines. Right at the top of the graph you can see our BV20 engine, which will produce about 9.4 megawatts, and the BV16 and the BV12. The BV12 is the engine that's been put into the Sheneve project, and you see the liquid fuel engines down here. My focus is on land power generation for gas engines. And when you think of the applications, what we can do for any country in the world, we can produce all of the basic power generation from full load to standby. We can do combined heat and power. We have greenhouse projects where the heat from our engine will generate carbon dioxide as well as power, and the heat for greenhouses as big as 12 football pitches. So we have district heating systems that they're applied to, and we have tri-generation systems whereby the heat can drive absorption chillers to chilled food produce. So as well as getting the power at very high efficiency, you get everything. The greenhouse projects even use the carbon dioxide from the exhaust gas. So the oil and gas applications is mainly power generation and pump drives with, to be honest, very few compressor drives. You can see our installed capacity around the world already, with a very heavy presence in Africa, Europe, Central America, South America and Asia. And we do have, of course, a big presence with marine industry in terms of the power generation and propulsion for ferries. This is very impressive Bergen engines in Norway with Rolls-Royce. We've delivered more than 650 medium-speed gas engines around the world with 26 million running hours. But what's very impressive is the 48% efficiency from gas fuel in to electrical power going out, which is very, very high. Nearly half of the gas energy that you put in is turned into electrical power. And when you get the tri-generation and the greenhouse projects with CHP, you can drive the cycle efficiency up to 95%, which is very good indeed. So this is just a general slide on how we lower emissions by displacing coal and liquid fuel and also providing flexible support for intermittent renewables such as solar and wind farms. And obviously the International Energy Agency is recommending these single engine units built into a stack or a cascade plant or single unit plants. So as we say, we can combine it as a hybrid solution with wind power and photovoltaic panels. And we also have, with intermittent engine demand, we can vary the power output with very large plants with cascade multiple engine installations. This is an example of a power barge application where it will be fueled by liquefied natural gas, again with the Rolls-Royce Bergen engines. We also cover long-term service agreements, so whatever country it's in, we can meet whatever the client or customer requires of us, from basic support all the way through to operation and maintenance of the power plant. So each long-term service agreement will be tailored to suit exactly what you require. So just a few reference projects then. This is a project in Mozambique, near South Africa, and it is for 13 BV20 engines, 20 cylinders, given a general output of 100 megawatt and a gross output of 122 megawatt. And there you can see the engines being lifted off the ship. We have a similar one in Tanzania, 60 megawatts for 10 BV16 engines. And this is in Myanmar, which is formerly Burma, as you know, and it's a lot smaller installation with 3 BV20s. And again in Bangladesh with a very similar installation. This is an interesting one. We have 4 engines in the Czech Republic, and the client is paid to have these engines on permanent standby. And he gets paid for that, and these engines have to be proven to run up to full load, or at least 80% of the load, within 5 minutes from a standby situation, which takes some doing for a BV20 engine. And we've achieved that in about 4.5 minutes, from stood still to full load in 5 minutes onto the Czech national grid. So that is another quite an impressive project. And here's one where we have heating and cooling in Italy, again with 3 BV20 engines producing 25 megawatts. So you can see a selection of projects there. What I'd like to do now is give you a little focus on, a quick focus on the Mozambique project, which is 13 engines. So I'm just going to briefly talk you through how that project is developing. Get the next one. That one there. That's it. That's it. Right. So we want to work with EPC contractors all around the world. But more and more we are finding that some of the clients are asking for more and more from Rolls-Royce Bergen Engines. So we have to draw a balance sometimes between the client asking us to be the main contractor, but I think on many of our projects we are one of the main suppliers or subcontractors to people like Telemania. So this is a view of the Mozambique plant. This is just a general view, a plan of the plant. You can't see much from that one, but you see a lot better from this diagrammatic of what the plant looks like. And I'll show you how simple power plant design is, says he. Right, this is the Rolls-Royce Bergen engines, and you can see down the engine hall, and you can see the 20-cylinder engines with the gas facility coming in here, and we'll go through how that is being built. This is the air intake filter system for the turbochargers on the engines. The turbochargers help to give us the increase in efficiency, and the air has to be spotlessly clean for the turbochargers, which is basically a turbo compressor. These are the pipe modules, so the balance of plant that we need for the engines, such as lube oil filters, heat exchangers, pipe works, pumps, are built into modules to make it very simple to ship and to install. These are the radiators, so the heating circuits for the engines. You can either use the heat, or for simple cycle, you can cool the engines via fin fan coolers. So you can see all the radiators there. These are the expansion tanks that we need for the water systems on the engine with the crankcase vent filter. So these are out near the roof of the station. This is the ventilation system, which is very important, as that provides all the cooling for the engine and alternator. And you can see it's a very modular system. These are the pipe modules I was referring to earlier on. So you can see all of these in a line together, one for each engine, with full access all the way around them. And these can be designed and built and sent over to the country like that. Right, so now I'll show you how it all goes together. So these are the foundations for the Mozambique project. So the likes of Telemania would currently be doing that if it was the Genève project. This is the main building that houses the engines. This is the engine room showing the 13 engines and the overhead crane facility. Sorry. This one shows the pipes and the pipe modules being installed for each engine all the way down the engine hall. The ventilation units that we saw on one of the previous slides, again, they provide all the air for cooling and ventilation, but that's got to be very clean also. And we see the air intake filters on the outside of the building. So these are the platforms around the engine. So every engine has got very good access for operations and maintenance. And we see the exhaust chimneys with silencers to meet the noise levels going to exhaust to atmosphere. This particular project, the radiators were an optional solution, so you can recover a lot of the heat through waste heat radiators. So we put the exhaust ducting in for the ventilation, so all of the air is drawn through. Then we put the pipe work in to the cooling circuits. And then we put the switchyard in for the HV connections from all the generators onto the national grid. There you are, power plant design made simple. Thank you for your attention. Once again, thanks for the warm welcome, and I wish the Genève project and Telemania every success for the future. Thank you very much indeed.